My dear students, now we are going to look at the design of Mod-10 synchronous up counter, also known as BCD counter. Of course, BCD synchronous up counter. Now we know that there are certain steps that we need to follow in order to complete this design process. This Mod-10 counter will be counting from 0 to 9. So first we need to find out the number of flip-flops required. So there are 10 different states. The states that we are, it is the state that is moving from 0, 1, 2, 3, 4, up to 9 it will go. Then after that 0, then once again 1, 2, 3, so on and so forth. So to represent 0 to 9, okay, there are 10 different values. We need how many flip-flops? So this n, capital N value, modulo n value, n is 10 given. What we know is 2 power n should be greater than or equals to capital N. So 2 power n should be greater than or equals to 10. What is small n? Small n is number of flip-flops. Number of flip-flops. So what I try to do is just I look for the different values. If I make 3, 2 power 3 greater than or equal to 10. So it is false. 2 power 3 is 8, 8 greater than or equal to 10. Not possible. Let's say n is equals to 3 here. Let's say n is equals to 4. So 2 power 4 greater than or equal to 10. So 2 power 4 is 16 greater than or equals to 10. So the smallest value of n for which this condition is valid is n is equals to 4. So the number of flip-flops required is 4. Okay. Or if I take 4 flip-flops, general common sense, let's say the outputs are QA, QB, QC, QD. Okay. So the first value will be 0, 0, 0. Last value will be 1, 1, 1. Totally we will get 16 different states. But we don't want 16, we want only 10. So obviously I need to go to for 4. Or if you take it 3, 3 0, 0, 0 to 1, 1, 1, which will give you only 0 to 7, 8 possible combinations. But what we are looking is 10 different possible combinations. Obviously I need to go for one extra flip-flop. This is for general common sense. Okay, anyhow we have a formula. From that we have calculated that n is equals to 4. Okay, so n is 4. Once this is clear, then we need to choose. This is what exactly that we are discussing so far is step 1. So in step 1, what we are trying to do, determine the number of flip-flops required. Number of flip-flops required at 4. Choose the type of the flip-flop. The type of the flip-flop, nothing is mentioned here in the problem. Let's suppose. In that case, what we try to do is, we try to use T flip-flop, toggle flip-flop. Draw the state diagram. Yes, now we will draw the state diagram. So step 2, in step 2 what we try to do is we are going to mention that okay, what is step 2? In step 2 we are mentioning that we are going to use T flip-flop. Then we will go for step 3. So in the step 3 what I need to do is I need to draw the state diagram. So present state is 0, 1, 2, 3, then 4, 5, 6, 7, 8, 9, 10. So 0, 0, 0, 0, 0 to 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, then 5, 6, 0, 1, 1, 0, 0, 1, 1, 1, 1, 0, 0. Okay. So 1, 0, 0 is 8. Then what we need? 1, 0, 1, 1, 0, 0, 1. So we have an extra one. So we will remove it. What we try to do is just we will take some space here, then we will draw it. So what I am going to get is 1, 0, 0, 1. So 0, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9, 9 to 0 back. So this is what exactly known as state diagram. So once state diagram is done, what is the next step that we need to do? We need to develop state excitation table for the counter. So step 4, what I am trying to do is excitation table for what exactly required? For mod 10 synchronous up counter. What is up counter? It will go from 0 to 1, 1 to 2, 2 to 3, so on. From the above diagram, what we know is state diagram. From that, what I try to do is I write the excitation table. So what I try to do is I take the 4 flip-flops. Let's say present state, next state, then flip-flop inputs. So present state is say QA, QB, QC, QD. QD plus 1, QC plus 1, QB plus 1, QA plus 1. Okay. Then we are going to look for TD, TC, TB, TA. Once this is done, then we will going to get the expressions for TA, TB, TC and TD. So for 0, 0, 0, 0, next state is 0, 0, 0, 1. For 0, 0, 0, 1, next state is 0, 0, 1, 0. Okay, 0 to 1, 1 to 2. For 0, 0, 1, 0, the next state is 0, 0, 1, 1. For 0, 0, 1, 1, the next state is 0, 1, 0, 0. For 0, 1, 0, 0, what exactly is? For 0, 1, 0, 0, that is 4. Next is 0, 1, 0, 1. For 0, 1, 0, 1, the next state is 6, 0, 1, 1, 0. For 0, 1, 1, 0, okay. For 0, 1, 1, 0, next state is 0, 1, 1, 0. Next state is 0, 1, 1, 1. For 0, 1, 1, 1, next state is 1, 0, 0, 0. For 1, 0, 0, 0, next state is 1, 0, 0, 1. For 1, 0, 0, 1, 1, 0, 0, 1, next state is 0, 0, 0, 0. So what exactly that is happening is we will be moving from the one state to the other state. Okay. Then we are getting the required state. What I try to do is next I will be looking at the comparisons. You try to look at QA and QA plus 1. From that you write the TA values, TB values, TC values and D values, of course. If in the input is anything greater than 9, okay, what exactly that we are expecting is don't guess. So either we can write it here or we need not write, or simply I can say anything greater than this will be considered as don't guess. So if that is a case, that we will include in the okay K maps. Now what I try to do is I will try to compare the values. This is 0, here it is 0 and here it is 1, right? So 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0. Always it is different. What we know from the T flip-flop, Qn plus 1 TA input. For 0, 0, input is 0. For 0, 1 or 1, 0, input is 1. For 1, 1, input is 0. So we are, from this what I can say is TA is 1, is 1, is 1, is 1, is 1. Once again 1, 1, Okay, 1, 1 and 1. So totally 10 ones. 3 plus 2, 5. 3 plus 2, 5. Next you compare QB with QB plus 1. QB with QB plus 1. So 0, 0. So 0, no change. 0, 1. It is 1. Right? Next 1, 1. No change. 1, 0. 1, 0 is 1. So 0, then 1. Next 0, 0. No change. Next 0, 1. What exactly? 1. Okay, from excitation table. So next 1, 1, 0, 1, 0, 1, 0, 0, 0, 0. Next what exactly we are getting? 0, 0 is 0. Then 0, 0 is 0. Is that fine? So next what we try to do is, okay, we will go for QC and QC plus 1. So if you see this 0, 0, 0, 0, 0, 0. So 3 times it is 0. Next it is 0, whereas this is 1. So it is 1. Next 1, 1, 1. 1, 1, 1. Okay, 1, 1, 1, 1, 1, 1. So 0, 0, 0 3 times. 1 compared with 0, so it is 1. And what about these two zeros? These two zeros. Okay, so this is 0, this is 0, this is 0, this is 0. So 0, then 0. Is that fine? Next what we need to do? We need to look at the TD. So from here to here, see here, this is 0, this is 0. And it is 0 up till here. But here it is 0 and it is 1. So this is 1. What about the rest? This is 0. This is 1, 0. Once again it is 1. But rest of the inputs are zeros because they are same. Okay. Once this is being done, we can get expression for TA. TA is function of what exactly it is? QA, QA, QB, QC, QD. So QD, QC, QB, QA. QA is LSB. Similarly, TB is a function of the same. TC is function of the same. And TD is also function of the same. So what we try to do is, we use K-maps and we try to write the expressions. Okay. So what I can do is, in this table, anything greater than this, okay, is exactly, we can write all 6 possible combinations. Your output is don't care. So what is the next value to 1001 is this 91010 till 1111. These are all don't cares, don't care, don't care, don't care, don't care. Okay. So this is all don't care, don't care, don't care. Last also don't care, don't care, don't care, don't care. And here also it is don't care, don't care, don't care. Because once it is nexted is don't care, obviously. So this is also don't care. So what exactly required is, okay, this complete table data. So what I can say in simple words, don't care terms are 10, 11, 12, 13, 14 and 15. Now what I want is, I want expression for TA. So if you need expression for a TA, draw the K map. How many variable K map? 4 input. So 4 input means 4 input K map. Okay, or 4 variable K map. So what are the LSB and MSB values? Here it is QD QC is your MSB, QB QA. 0 0 0 1 1 1 1 0, 0 0 0 1 1 1 1 0. What we have got here is all ones followed by don't care. So this is don't care, 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 because we know the cell numbers. Rest all are ones for TA. So once I combine everything, if I combine everything, what exactly that I am going to get is, all combined, that is nothing but TA is equals to 1 forever. Similarly, what I can do is I can work out for TB, okay, draw the K map, okay, work out for TB. So this is a K map for TB. This is K map for TA. Next I will draw K map for TC. So what I try to do is just I'll enter the values of TB into the map. I'll solve for it. Similarly, I will have a K map for TC. I'll draw the K map. Then I'll enter the values of TC into the map. Okay. This is QD, QC, QB, QA, 00011110, 00011110, 00011110, 00011110. This is QD, this is QC, this is QB, this is QA. Okay. So as usual, 10, 11, 12, 13, 14, 15 are don't cares. Rest of the values from the above table we can get it. So we can enter this don't cares directly. Then rest of the numbers. Okay. Now if you look at it, say for example, for TB it is 1 for 010101, right? This is what exactly the sequence we have till 9. So 0101. So it is 01, then 01, 01, then 01. Okay. Then what exactly we have? What exactly we have? The expression for TB is this much. That's all. Rest all are zeros. So what I can do is just I can take 4 ones as a combination. Which 4 ones is this? These 4 ones I can take a combination. So what I left with is the expression for TB. It turns out to be QA, right? So for TB, what we have is here it is QA. So from here it is QD bar. So it is QD bar or QD bar QA. Okay. Similarly, what I can do is I can enter the values of TC. If I enter the values of TC, it is only 1 for 3 and 1 for 7. So if I combine them, I am going to combine this. Rest all are zeros. So your TC turns out to be, what is that value is QA and QB. So that is QB, QA. Similarly, what I can do is I can enter the values of TD in a K map. So if you enter the value, if you look at the table and enter the values, okay, this is don't care, this is don't care, this is don't care, this is don't care, this is don't care. You will get one here, one and one here from the table. Of course, it is the same. It is QD, QC, QB, QA, 00011110, 00011110. Then you are going to get expression for TD. So what I can do is I can go for this 4 and I can go for this 2. So what I can do is just I can show you that I can go for this 4, this 4. So this 4 I can go for. Then I can also go for this 2. Okay. Then I can write the expression. Once I write the expression, then what I need to do, I need to draw the circuit diagram. Of course, we have seen number of times how to draw the circuit diagram. So one can draw the circuit diagram. What is the expression that I am going to get for TD? For expression for TD will be expression for TD. Expression for TD I need to look at. So TD turns out to be QA QD, QA QD plus QA QB and QC. This is what exactly the expression is. So from this four expressions, you can draw the circuit diagram. How the circuit diagram will be, how it look like. Now let's draw the circuit diagram. So I have a flip flop here, then I have another flip flop here, I have another flip flop here. Totally four flip flops I have, right? So this is flip flop A, flip flop B, flip flop C, flip flop D. Okay. So what is TA? TA should be always high. So this will be connected to 1. There is a QA, of course, and there is a QB. This is a TB. This is a QB. This is a TC. This is a QC. This is no. This is D. We have mentioned as D. So it is TD. We will follow only one thing because we have written D here. It should be D. We have written C here. It should be C. So just we will make it as C. This is C. Of course, this is B, and this is A. So T, if this is TA, it is always 1. This will be QA. Either way we can represent. So we can represent this one as A, this one as D, or this one as A and this one as D. Either way is possible, but the expressions whatever we have, accordingly we need to do it. So TA is 1. What is a TB expression for TB? Expression for TB is QD bar and QA. So TB is here. This is your TB. For this we will use an AND gate. So what I do is I will use an AND gate. One of the input is QD bar. From where I will get QD bar? This is QD bar. It is QD. Okay. So this is QD bar. From here I need to make a connection. I am not showing. Okay, I don't want to make it complex. Okay. So one of the input is QD and one of the input is QA. So QA is here available. QD bar is available here. We'll take both of them and give it to the AND gate. Similarly, if I look for TC, TC is QB QA. So QB is available here, QA is available here. So this is your TC. For this TC, what we try to do is we will use an AND gate. Okay. For the AND gate, one of the input is QB, another input is QC. QB QC, right? No, QB QA. So another input is QA. So we have QA, we have QB. So QA QB we are using to TC. And what about TD? TD is having two AND gates and one OR gate. So what I try to do is I will take one AND gate, then another AND gate, then I will give it to OR gate. That I am giving it to TD. The inputs for the gates are, one is QA, another is QD. Okay, for other one they have three inputs. The three inputs are QA, QB, then QC. From this, what exactly that I am going to get is for all the flip flops, what I need to have is I need to have a common clock. So there is a common clock here, common clock here, common clock here, common clock here. So the clock is common, inputs are derived. So this is nothing but mod 10 synchronous, okay, up counter.